Hello everyone, in this video we are going to say about deep neural networks. Before that, let's see what is AI, ML and DL. So AI is from the word itself, artificial intelligence. So we are providing a machine with intelligence, with the ability to mimic the humans, to make decisions, whether it is an yes or no or multiple choice decisions. Likewise, ML. So, machine learning. We are making a machine to learn, to obtain knowledge from data. That may be a historical data by means of different types of learning. And DL is deep learning. Same goes here where we are making the machine to learn with data that may also be unstructured data. So the unstructured data, maybe images, videos, likewise speech, everything. So in that there comes DNN, deep neural network. Let's see what is DNN. So how in humans the brain works by means of neural networks. Likewise, we are making the machine to work by means of different types of layered of networks, that is the neural network. So neural network is an advanced type of artificial neural network which comprises of the multiple layers. We will see what are the layers in the further slides. So these layers will involve in the processing and functioning of a complex task which involves such as image processing, speech recognition, language translation and many other different types of applications. So, in deep learning, DNN is a very important part and in means of the field of artificial intelligence too. So now let's see about the architecture of DNN. There are different types of layers involved in this architecture along with the functioning too. So in architecture, first layer is input layer, next is the hidden layers, which is the functional layer, next is the output layer and it also with activation function. So from the starting itself, for processing, we need with provisioning of an input. Then only it will comprises of the processing and will provide with the output, right? So likewise, the input layer will obtain the input that may be image, texture, audio, signals, everything. So it will not perform any function. So there is no computations are performed here. Whereas in multiple layer it performs a function I have already told you. So here it is a computation layer which performs the function, that is an activation function with means of weight parameters. So let's see what is an activation function in further slide. Here there are multiple layers in hidden layer itself with low level to higher level layers. So it will perform with the simple patternages or deep concepts like object meaning, text, etc. So next is the output layer. So here from the activation function, you will obtain the output by from hidden layer to right. Here you will obtain the output which is predicted, the final thing. And the activation function is the function which performs the some processing, which is obtaining the input by means of weight, it computes and provides with the output. That is the weight parameter. So there are different types of activation functions such as ReLU, linear, sigmoid, and tank. Let's see the architecture of DNN. Here from this you can understand the types of layers, how the layers are is like a neural networks and how the nodes here are representing the neuron of our brain, like In input layer, you can see circles with blue. That is the nodes of the input layer, which is provided with the input function. Sorry, input. And in the hidden layers, there is multiple hidden layers of dirt. Here, it comprises only of two hidden layers, and the output layer, which is in violet circle node. The nodes, two nodes, represents the output layer. Here you can see how it performs with forward propagation and also with the backward propagation. We will see that later. So I will show you how it works. In these are the activation function, that is will obtain the inputs from the input layer, that is x1 x2 x up to xn, or the input, where is represented x in the activation function along with the weight parameters, that is represented here as the w 1 to up to wn, right? That is a bias parameter too. So with the summation of the weight parameter and the input symbol with the bias is the activation function, which will be repeated several times until you will get the target output. So this is the output for our processing in DNN. So that's what the activation function is given here. This is the activation function. Y is equal to f of function of wx plus b. Here y is the output, w, w is the weight, x is the input, and b is the bias. I think you get it. Next, let's see the working of DNN. I've already told you how the input comes and how the performance will occur in the input hidden layers, and the output layer will obtain with the output, right? So that's what given here. So from the input layer to the output layer is known to be the forward propagation here. So the input data follows from the input layer through all the hidden layers to the output layer is the forward propagation. So the neuron will perform with the activation function. You get it. Next is the loss function. And the loss function is nothing but in the processing, you will need to obtain a target output. That is, if you are providing with an image with tree as an input, so the neural networks will perform the function and provide you with the output as tree. Here, when it provides with the output as leaf as an output, but actual output is, that is the target output is tree, right? That is a correct output. Here you will, the output is leaf, so you need to repeat the process until you give the output as tree. This is known to be the for this what happens, and through which the forward and backward propagation will happen in DNA. So here you are going to see forward propagation, loss function, backward propagation, and with the optimal algorithm, optimization algorithm. Now let's see the loss function. So the difference between the target output and the actual output is the loss function. Until you obtain the target output, you will repeat the process. The loss function is nothing, the difference between them. If there is no difference, then you will achieve with it. So there are examples for it, that is mean square error and the cross entropy loss. Next is the backward propagation. So I have already told you the forward propagation, and what might be the backward propagation. It will just like backtracking. It will goes to from the output to layer to the input layer. That's what here comes. So to get higher accuracy. So the way will be calculating by calculating radius of loss the with right to weights has the network minimize loss and improve accuracy. Next optimization algorithm is adjusting. It used in adjusting weight, right? That is, firstly there will be a weight. and then there will be changes in weights every time you repeat the process, and every time it moves up with the one layer to the another layer. So what will be the change in weight is depends on the optimization algorithm. There are different types of algorithms: gradient descent, Adam and RMS probe algorithms, and where in the optimization algorithm and changes in weight, adaptations in weight will most commonly come up with the loss function along with the weights, along with the inputs, and then with the learning rate. So the learning rate will be up to the maximum amount is 1, that is will comprise with 0 to 1, that is the limit, and the inputs right or outputs right, whatever it will come will be in the binary data, zeros and ones only. I just gave you as an example, but it will be in zeros and ones, and that's how the functionality will be there. Okay, so next see the diagram for it. So from this you can come up with the easy understanding. I have already told you, right? So from input to output is forward, and output to input layer is the backward propagation. That's what is given here. So by seeing this, you can come up with a clear understanding. And loss function is what, and this is how it repeats iterative process of this. Okay, let's see training process of DNN. So from walking of DNA itself, we can come up with how it gets trained, right? I've told you there will be an input along with the weight parameters. It will be computed by means of the layers, and it will come up with the forward propagation to the output layer. It also involves in calculating the last function is given here, and then if it's not up to the target output, it comes up with the backward propagation again until it will get the target, and the weights will be updated by means of the optimization algorithm. So there will be multiple approaches. Why? Because this is how the approach is there, the repetition of that to get an accuracy in your output. That's it. So this is how the data is trained. Next, see the important feature of DNN. So, what will be the important feature? You have already seen there are layers of functionalities. That is, there are layers of structure, hidden layer, output layer, input layer, right? So that's what the hierarchical featuring in DNN. So that multiple layers in mainly in the hidden layer itself comprises a multiple layer where lower level layer only performs the basic features, middle layer will perform with patterns, and higher level layer will perform with the full concept of it, right? There it will also performs with the non-linear relationships too. So the activation function is capable of it, and scalability. That's the main thing. Where compared to the ML, right? It will perform with, I've already told you, unstructured data too. So it will perform with big data and complex tasks efficiently. That's what scalability means. Next, see types of DNN. So which involves CNN convolution neural networks that process mainly with image and video, or NN, that is recurrent neural network, which performs with speech and text and sequence data to auto encounters, which will involve in the dimensional reductions and noise removal, and GAN, generative advertisable networks from the name itself, which helps in generation of image. DBN, deep belief networks, is the probabilistic models. So these will perform with the specialization in variance versatile applications. Next, see the applications of DNN. You can just come up with this from your real time examples, like when you're open your phone, you are having with the lock of it. For opening it, there are different types of lock sensors, which involves the facial recognition system there. And we are using the Google Assistant, which comprises with the speech recognition, and NLP, natural language processing, is also there. And your YouTube, you're watching that, right? Which comprises of recommendation systems, which will recommend you whatever you see with the algorithms. And there is a fraud detection in banking and self-driving cars are there, and medical image diagnosis is also there. So there are multiple applications of the neural networks, sorry, DNN. And advantages is yes, we have to come up with a high accuracy, it performs the complex tasks too, and automatic future, sorry, an automatic future is there without manual input. That is, we can come up with the sensor is the input also with the unstructured input to handles high dimensional data. That's what here given. High dimensional data is unstructured data. Handling is also the allows non-linear relationships yes with generalization well sufficient data. Let's come up with the challenges. The challenges request data sets for effective training. Yes, you can see for training you have to it will take large amount of time since it's a large set of data. So it comes up with problem of overfitting too, and the competition is expensive too, and it is difficult to interrupt. This is again. So in conclusion, is very DNN is very important and powerful tool in modern AI. It implicates the human brain learning process and solves the impossible traditional ML, and it provides with a high accuracy, and it's used in many industrial activities nowadays, and then also a foundation for the development and evaluation of the technologies, which involves in examples like autonomous vehicles, natural language processing, advanced medical systems, etc. So in this video, we have seen about the deep neural network, and it's very important in your life cycle too, right? Thank you for watching. See you in the next video.